In the last video, we created a very simple Manim workflow that could generate Manim videos from just a prompt. On the right here, you can see the exact workflow we used, and we didn't use any abstraction. It was purely just Python code. And at the end of it, you could give it a prompt and it will create a video in 3 blue, 1 brown style. Now, today, what I want to do is take it from just that Python code and essentially orchestrate the whole thing in LangGraph. Now, what is LangGraph and why do we need it? Let's take a quick detour to talk about what LangGraph is, and I'll explain using very simple language that makes sense to everyone. If you are already familiar with the framework, feel free to skip it. I'll include maybe some timestamps in the video so you can skip the next 3 minutes. Software engineers are like mathematicians. They like to invent complicated terminology to explain simple things. Now, LangGraph is a low-level framework for building controllable agents. But once you start learning the basics here, you quickly run into terms like state graph and things like nodes and edges and memory checkpointers. And you're like, okay, what the hell is this? So let me explain this whole concept using a very simple visual example. Imagine you have a video production team. You have a scriptwriter who writes a script, goes to the director tells the videographer what scenes to shoot. If the scene looks great, okay, we have a video. If not, we have a troubleshooter who can fix these things on the fly. Now you can imagine they probably have some kind of shared project directory, a folder. Maybe it's a Google Doc that has all of this different information that gets passed to different people at different times. Now, if you want to make some analogies to how LangGraph works, here is a good way to think about it. The whole production plan, aka exactly showing how the video is made, who works on what, in what order, that is what the graph is. And the nodes are these specialists. So a scriptwriter's function is to write a script, and that is a node. Now, sometimes people think that nodes have to be wrapped up in like LangChain or whatever. No, it can be any arbitrary function. It can be a LLM call. It could just be a function that adds 2 numbers. It could be literally anything. The state is this Google Doc. That's the shared project folder. And so the scriptwriter puts the script in, the director puts the scenes in, and that's what gets passed down to different people. Now the edges essentially describe who gets the project folder next and what path does the project take from one place from the start to finish. Conditional edges are essentially decision points. So think of it as like, in the flow chart, it's like, hey, did this work? If yes, go right ahead. If not, let's fix it and go from there. Now, checkpointing is like automatic saving feature from Google Docs. Everything gets saved after each person finishes their part, and you can pick it right up wherever you left off. You can also go back to the previous version whenever you need to. And then thread IDs are just like project numbers. It's like a tracking number for a package. It allows the system to keep multiple projects separate, and you can resume work on a specific project at any time. Okay, now the question is, why should we use LangGraph? If we can just write the whole thing in Scratch in Python, why do we need a framework? LangGraph does have certain advantages, and we can talk about like the top 4 that are relevant here. The first thing is that instead of writing a bunch of like if-else logic, you can define your flow declaratively, and this makes the logic easy to visualize and then to debug. It also separates the logic and the execution. The second big feature is that it does have automatic, memory checkpointing, which means that the state or the dictionary that we're passing around through the whole workflow is automatically saved after the last completed node. And so this makes, like, if you have a long LLM chain or some kind of acyclical workflow, it makes it more robust. And if you were using pure Python, you will have to write down custom logic for saving and loading intermediate states. Thread IDs, as we talked about, are just ways to basically support multiple executions and then you can resume whichever one you want at any time. And this way you can keep different executions isolated and separated without writing your own tracking system. It's one cool thing about LangGraph is that obviously it has a graph, so you can debug and visualize and log different things. But LangChain team also has an observability software program called Langsmith, and LangGraph essentially just integrates natively with it. We'll see later that you can just use a decorator and an API key, and then you can go to Langsmith to see which node invoked which calls, what was the output, what was the input, how long it took, where it failed, all these different things. And I'll show you a little demo which talks about it. So quickly, I'll just do a quick run through of the code, not dive too deep into it, so the video is not super long. But yes, these are essentially the same system level dependencies you have to install. You may have to restart the kernel. And then this is also the same, except you have an additional LangGraph installed this time. Again, we'll load up the API keys. And these are all the things that were present in the last notebook. The link is here if you want to check it out. But essentially, it's the base class template. Then all these system prompts have kind of refactored them into simple functions, so we can just invoke those functions instead of making the invoking LLM functions like really, really long and verbose. And so that's pretty trivial. And here we have pretty much the same imports as before, but we have a few extra imports because of LangGraph. And then again, this is our state schema just like before. The new thing here is that we now have the state, which we're going to pass around for LangGraph. And so it has the prompt that's inputted by the user. These are basically like key value pairs. And for certain things like plan and code and stuff, you can still use these Pydantic models. And so it has this optional type. Typedict obviously is just like a type safe dictionary in Python. Now, if you look at the code before, we had a function which basically was used for planning the scene. So it had system prompt, which was pretty long, and a user prompt, and basically it will kind of get the response from the OpenAI client. And to convert this into a LangGraph node, it's pretty easy, and that's what I do here. I mean, instead of passing just a prompt, you just pass the state, because I mean, this whole LangGraph thing is a state machine. So you pass the state and you get the state out, and then everything else is pretty much the same. And then in the end, you can just update the state with whichever things this plan scene node updates. So it will update the plan and the scene name. Same thing with all these different functions that we were using before. We'll just convert them into like LangGraph nodes. And then, so you have one for planning, then you have one for generating code, and then you have for execution, which will probably be just exactly the same as before. And then you have the error correction nodes, right? Now, in additional, instead of an if-else statement, we have basically this node that decides whether there were errors or not. And so if it was correct, if the execution result was successful, it'll say finish. If it's incorrect, it will try to turn correct, and that will decide where the workflow goes. So if it's finished here, it'll basically output the video. If not, it'll try to go to error correction node and go from there. This is where you build a LangGraph workflow, right? And so essentially you initiate the state graph with the Manim state that we talked about before, and then first you will add all the nodes. So we have the plan scene node, the code generation node, the execution node, or correction node, and then you will try to define the edges that connect them. So obviously from start we have start to plan scene, and then from plan scene to generate code, and then from generate code to execute node, and then this is where the conditional edge comes in. So essentially, once we execute code, it basically goes to this function that we defined before, which was like, should you correct or finish? And if it's correct, it should go to correct errors. And if not, it should go to end, right? And then we will initialize the memory saver for checkpointing, and you compile the workflow. You can use mermaid diagrams to essentially visualize what this workflow looks like, and this is really helpful in terms of visualizing like what's going on. So again, this is a good sanity check to make sure that whatever you visualized in your little hand-drawn diagram is what it comes out to be. And that seems good. Then we just write a function to generate the workflow. And so obviously you have to first initialize the initial state, and the initial state would just be the prompt, and everything else will just be none or some value that's default. And then from here, we use that function that we had just written to build the Manim, the LangGraph graph. Here we can have a thread for persistence, and you just run the workflow, you get the result. And so if you ask whatever question you want to ask, I'm asking explain quantum entanglement, and then you can see that it goes through these things, and every once in a while it'll run into some errors, right? So here, I don't know, there is some animation that failed to render. I don't know why that is, but let's look at it really quick. Okay, it's using some method show creation that it's deprecated in Manim now. It's not part of it, and so you have to use create method instead. And so it tries to correct it, and when it corrects that, maybe called scene play that didn't have any animations, so it basically corrected that as well. And luckily, in the third try, it got it. And so this is the final video. Obviously, lots of optimizations to make. The prompts, I'm not saying the prompts are great. We can improve those. And it would be amazing imagine if for like code gen and for error correction, it had access to Manim's API and some examples of Manim code, so it doesn't make these silly mistakes like using like deprecated methods or using wrong attributes. And so that'll be the topic for the next video, I suppose. You can add tracing very simply in LangGraph. And let me just show you how the whole tracing thing works. So this is the alpha that's in production, and somebody asked, I don't know, what was the question? Like, how does a ball bounce, right? Some very basic question. And so you can go through these different nodes. So like plan scene node essentially says, okay, so obviously in production, I have some reformulation and stuff where like if the question is not detailed enough, it basically adds some detail. So it reformulated the input as like, okay, what are the physical principles that explain how a ball bounces? And then this is the output on the plan scene node. So it says, okay, this should be the scene 1, that should be scene 2, this should be scene 3, and then scene 4 summarize, and these are the visual and style nodes. And so then the generate code node is here, and basically we'll take this input and generate this code output, right? And so the advantage of having tracing is that for every question in your application or your LLM workflow, you can see what the input and output was, what the latency was. There are ways to add, there are ways to certainly see how many tokens were processed and stuff. Right now, I'm keeping it very simple, so you don't see a lot of that. But I have left that as homework to do. All you have to do is add like Langsmith tracing equals true and put the Langsmith API key, which you can get from the website. And if you look at, there are the keys, right? So you can add these environment variables here. And if you want to read more details on how to do that, go to this link. You can, by the way, forgot to tell you this, but you don't have to add any more code except just decorate the functions with traceable. And it'll natively just trace all your Python functions and calls. And then you can go back to the Langsmith thing, and you can kind of see for different invocations what are the different inputs and outputs. Okay. I think that's really it. Let me know if you have any thoughts or comments. Thank you.